Welcome to the lesson Hypothesis Test for a Population Mean. Here we do assume sigma is known. Statistical inference. Confidence intervals are one of the two most common types of statistical inference. In the previous video, I discussed confidence interval. When sigma is known, confidence interval was x bar plus or minus z star sigma over root n. The second common type of inference, called test of significance, also called a hypothesis, has a different goal: to assess the evidence provided by data about some claim concerning a population. Hypothesis is a statement about a population parameter. What we are going to discuss in this video? Let me explain using this example. This is a rice bag. So, what do you think about weight of this rice bag? I say it is 25 laps. How do we know that? Can you believe it? We can believe because it is on the label. But have you ever measured this rice bag? How about if we pick 10,000 rice bag? Do you think each of them has the exactly 25 laps weight? Yes, then we have a question. What is the question? On average, is there exactly 25 laps in each bag? So we have a population, so we cannot measure each bag, but we can pick a sample and then measure their weight. Using their weight, we can check whether this on average there is exactly 25 laps in each bag. So that is the type of problem we are going to talk about. Hypothesis testing. Let me give you some examples. Need to decide whether the mean weight of rice bags is exactly 25 laps. Yeah, same thing what we discussed before. Need to investigate whether the average cholesterol level of female college students is higher than that of male college students. Here we compare two groups, female student and male student. Want to test that the smokers need an average sleep greater than 7.7 hours. One of the most commonly used methods for making such decisions or judgments is to perform a hypothesis test. A hypothesis test involves two hypotheses. First one is null hypothesis. We use H naught to show null hypothesis. A hypothesis to be tested. The null hypothesis for a hypothesis test concerning a population mean single value for that parameter. Hence, we can express the null hypothesis as is some number. Right, next one is alternative hypothesis. Here we use H1 or HA, either one. A hypothesis to be considered as an alternative to the null hypothesis. The choice of the alternative hypothesis depends on and should reflect the purpose of the hypothesis test. There are three cases here. I can say first one, null is mu equal mu naught versus alternative is mu greater than mu naught. What is the second one? Yes, null is mu equal mu naught again versus alternative is different, mu less than mu naught. Last one, alternative is the different one, mu not equal mu naught. So you see here null hypothesis is the same, but alternative is different. Mu is the parameter. Again understand this. Mu naught is what? Mu naught is a number, any number. That number depends on our question. That number depends on the research question, research problem. Right. How about this? Can I check H naught, x bar equal x naught? Again, x naught can be mu naught or any number. As an example, I can say x bar equal 10. versus x bar greater than 10. Can we use hypothesis to check that? Actually, no. Why? We don't use statistics for the null and alternative hypothesis. Why? Because we know that number already. We can calculate x bar, right? Because we have a sample, so we can calculate x bar. So why do we check again? Because we know already x bar equal, as an example, 10. It is coming from the sample, so we know x bar is 10. We don't have to calculate. Therefore, we never use statistic for the null and alternative hypothesis. Three choices are possible for the alternative hypothesis, as I explained before. So this mu greater than mu naught, mu less than mu naught, mu not equal mu naught. Again, as an example, I can use mu less than 9, or I can say mu not equal 10. So mu naught is a number. So you see first and second one, greater than and less than, we call one tail test. But next one we call two tail test. Okay, one tail and two tail test. But first one you see mu greater than mu naught is right tail. Yes, it is right tail test. So second one should be left tail test. Here you see, why do we say right tail? Because mu is greater than mu naught. So mu should be at the left side, right? Sorry, right side. That is right tail. Here mu less than mu naught, therefore mu is in your left. So it's left tail. So this is the two tail. We check both sides. Because we know we check only mu not equal mu naught. Suppose as an example we check mu not equal 10. Then it can be any number mu less than 10 or mu greater than 10 in the both side. That's why we call two-tailed test. Read this example. It is believed that a machine makes chocolate bars that are on average 5 grams. A worker claims that the machine no longer makes 5 gram bars after the maintenance. What do we need to check? Yes, a worker claims that the machine no longer makes 5 gram bars after the maintenance. So we need to check this claim is right or wrong. So variable defined on the population equal mass of chocolate bars. How do we check it? We say H naught mu equal 5 because that's the we believe. You see, it is believed that a machine makes chocolate bars that are on average 5g. Currently we believe it has 5 Gs, 5 grams. The claim is no longer makes 5 grams. It means he doesn't say less than 5 gram or greater than 5 gram. He just say it doesn't make 5 gram. It means it can be made, less than 5 gram or maybe greater than 5 gram. It doesn't matter. Just our point is it doesn't work properly. That's the main thing. So this test is classified as a two-tailed test. Why we say two-tailed? Because alternative is not equal. Mu not equal 5. In 2016, the mean retail price of history books was $78.01. Suppose that we want to perform a hypothesis test to decide whether this year's mean retail price of history books has increased from the 2016 mean. What is a variable? Variable defined on the population. Retail price of history books in this year. Yes, we are going to check about the history book, price of the history book, right? So what is our claim? In this year, this has increased from that price. Increase. Therefore, what do you think? H naught mu equals 78.01. but HA mu greater than 78.01. That's the claim, mu greater than 78.01. We need to check it. So this test is classified as a right tail test. You know it is right tail because mu greater than. A doctor claims that the daily calcium intake of the pregnant woman with low income is less than the 1000 milligram. Alright, now we are checking daily calcium intake of the pregnant woman. So, what do you think about H naught? H naught mu equal 1000 but HA mu less than 1000. Why? Because our claim is income is less than the 1000 milligram. That's the we need to check. Alright, so this test is classified as a left tail test because mu less than 1000. Definitions: p-value. The p-value of a hypothesis test is the probability of getting sample data at least as inconsistent with the null hypothesis and supportive of the alternative hypothesis as the sample data actually obtained. Then significance level or level of significance, we use alpha. The probability of rejecting the null hypothesis when it is true. Alright, you know already we discussed confidence level in the previous video under confidence interval. So, confidence level we use C, significance level we use alpha. There is a relationship between this. What is the relationship? Significance level equal 1 minus confidence level. That means alpha equal 1 minus C, or we can say C equal 1 minus alpha. So alpha normally is small number like 5%, 10%, 1%, so on. But C we saw in the last video, it is big number 90%, 95%, 99%, 80% like that. Testing hypothesis for one mean test. Again, sigma is known. It is very important. We assume sigma is known. First, read the problem and identify the null and alternative hypothesis. It is very important. First case is mu equal mu naught versus mu greater than mu naught, or this one, or this one. We discussed this about these three before. Second one, decide on the significance level alpha. Identify the test statistic. Again, here sigma is known. Therefore, our test statistic is Z naught equal x bar minus mu naught over sigma over root 10. Again, Z naught is the test statistic. The third step, you should calculate the test statistic. How do you calculate test statistic? X bar minus mu naught. Mu naught is the value of mu under H naught. Mu naught is the value of mu under H naught. And divided by sigma is the population mean, root n is the sample size. Then we need to find the p-value. Yes, I will explain in a few minutes how to find the p-value. Once we find the p-value, we can decide H0 is rejected or H0 is failed to reject. How do we decide this? I will explain that too. Then give your conclusion. Return to the practical question to describe your results in this setting. Yes, then in the conclusion, you have to go back to the application. Then you should explain according to the application. Now let me explain how to find the p-value. So you know there are three cases of the alternative hypothesis. So first one I consider HA mu greater than mu naught. For this case, so this is the curve, normal curve, and you know Z naught. Z naught is the test statistic. So we consider the right corner. Okay, we consider the right corner. p-value is probability z greater than or equal z0. It means that is the area under the curve and greater than z0. You know how to check the table for this. Then we go to mu less than mu naught. That is left tail. So for the left tail case, we consider the left corner. But again z0 is the test statistic. So p-value is probability z less than or equal z0. Okay, now how about two-tail? Yes, two-tail test, we consider the both areas. You know, blue color area. Then how do we find the p-value? Yes, p-value is probability z greater than or equal absolute value z0. So here actually we find the probability or area under the curve and left side area and right side area and add them together. I will explain again how to find this using some examples. Criteria for rejecting null hypothesis. Now, how do we decide reject or not? We reject H0 if the p-value is less than or equal to the significance level. If p-value less than or equal alpha, then we say reject H0. If the p-value is smaller than or equal alpha, we say that the data are statistically significant at level alpha. In my next video, I am going to discuss more examples. So then before you go to next video, please understand this concept. Then you can watch my next video for the examples. Thank you.